The process of translation consists of three phases. The first is called initiation, the second elongation, and the third is termination. And this particular figure shows us information about the first of these phases, which is initiation, and the second, which is elongation. Initiation means to begin, and so we're beginning the process of translation. So we start with our messenger RNA molecule, and there is a portion of sequence that's going to be in front of the start codon, which you'll remember is the AUG. And so the AUG, the start codon, is responsible for building up of the translation complex. And the translation complex is going to consist of some proteins as well as the ribosomal subunits. You'll remember the ribosome is made up of rRNA and proteins, and it's responsible for coordinating the process of translation. So what we first have is the assembly of the small ribosomal subunit on the messenger RNA. These two white regions represent two regions of the ribosome called the P site and the A site. And the P site and the A site will contain a block of 3 consecutive nucleotides, which is called the codon. So when the small ribosomal subunit sits down on the messenger RNA, the AUG will be in the P site. The next codon, whatever it is, will be in the A site. Remember, AUG corresponds to a special form of methionine, and that's called F-met. And so remember, the amino acid gets brought in because of a tRNA with an appropriate or complementary anticodon. So if my start codon is AUG, A is complementary to U to A, and G to C. So the F-met tRNA molecule will come in, and because of hydrogen bonding between the anticodon and the codon, it will basically latch on to the messenger RNA. The second ribosomal subunit then comes in and complexes to create the functional translational complex. So the third position, which is now shown on the elongation, is called the exit slot. And so the exit slot is always there, it's just they didn't show it to you in the first portion. So I have my P site, which right now contains the first amino acid, my A site, and my E site. So remember, the second codon is going to be in the A site. So this particular codon is CCC. So if you went to the table of the genetic code, that would indicate the amino acid proline, or represented by the 3-letter symbol PRO. So the tRNA with the complementary anticodon, again in this case it would be GGG, comes in and brings in the next amino acid. Now, a chemical bond is formed between the two amino acids, and the amino acid in the P site will be joined on to the amino acid in the A site. At that point, the ribosome is said to shift, or they use the phrase scoot over. It shifts to the next codon. So what was in the P site is now in the exit site. What was in the A site is now in the P site, and the next codon to be translated is going to be in the A site. So you can see my first tRNA is now ejected minus its amino acid, so it's free to be recharged again by an amino acyl synthetase. My two amino acids are joined together, and my next tRNA molecule is going to come in, drop off its amino acid. This process of elongation will continue until one of the 3 stop codons is encountered, and we'll look at more information about that in the next figure.